we are gonna work on another linear programming problem. This one's a little bit tricky, a little bit tough, so that's why I'm gonna work it with you. Just to let you know, I don't think per se this one like this can be on the test because it's quite intensive. We're gonna go ahead and zoom in just a little bit, but you know, always good to be ready. So first thing we do is we read. A car dealer has warehouses in Millville and Trenton and a dealership in Camden and Atlantic City. Every car that is sold at the dealership must be delivered from one of the warehouses. On a certain day, the Camden dealers sell 10 cars, the Atlantic City dealers sell 12. The Millville warehouses has 15 cars available and the Trenton warehouse has 10. The cost of shipping one car is $50 from Millville to Camden, $40 from Millville to Atlantic City, $60 from Trenton to Camden, and $55 from Trenton to Atlantic City. How many cars should be moved from each warehouse to each dealership to fill the order's minimum cost? Okay, a lot of stuff going on in this problem. Sometimes when there's a lot of stuff going on, it might be beneficial to make a little diagram. So I'm just going to make a little diagram right here, okay? And let's see if we can make sense of some of the stuff that's going on. So we have this warehouse in Millville that has 15 cars. We have another warehouse over here in Trenton that has 10 cars, okay? So Millville has 15, Trenton has 10. Up here, let's say this is Camden. In Camden, they sold 10 cars. And let's say down here in Atlantic City, this is where they sold 12 cars. Okay, so this is kind of what we got going on. These are the warehouses with the cars. These are the ones that sold the cars. Now they got to get from here to here. So if I move a car from Millville to Camden, it says that it cost me $50. So that cost is $50. If I move it from Millville to Atlantic City, they tell me that cost is $40. Okay? Then they tell me from Trenton to Camden is $60 cost to move a car. And then they tell me that the cost to move from Trenton to Atlantic City is $55. So, again, a lot of information going on. Let's see if we can, again, just sort through some of this stuff. So, a couple things we do know. Well, let's go ahead. Let's go ahead and say, let's start with just Millville for right now, okay? Let's say that I'm going to let X cars, say I'm going to let X represent the cars, number of cars from Millville to Camden. All right? I'm going to let Y equal the number of cars from Millville to Atlantic City. Now, what do you know about total cars from Millville? What do you know about total cars from Millville? Well, the total cars from Millville, so in other words, X plus Y, would have to be smaller than or equal to 15 because Millville only has 15 cars in its warehouse. So it couldn't, like you couldn't send any more than 15 to either place. So X plus Y has got to be less than or equal to 15. Now if we take X cars from Millville to Camden, so if X cars go from here to here, this is representing X, then that means from Trenton to Camden would be however many cars Camden needs, which is 10, minus the ones that they're getting from Millville, which is X. So in other words, 10 minus X is how many cars are coming from Trenton. So that's equaling the number of cars from Trenton. Pushing too hard on my pencil. Trenton to Camden. Well, in the same idea, from Trenton to Atlantic City, if the numbers from Millville to Atlantic City, if the number of cars going from there is Y, then from Trenton to Atlantic City would have to be 12 minus Y, because they need 12, and they're going to get Y amount from Millville, so they only need 12 minus Y from Trenton. So 12 minus Y is the number of cars from Trenton to Atlantic City. So if I add these two together, so 10 minus x plus 12 minus y, that would have to be less than or equal to how many total cars I have in Trenton, which is 10. Which then, doing some quick math, 10 plus 12 is 22. So if I subtract 22 over, that gets rid of both of these. Subtract 22 over, that gives us negative x minus y less than or equal to negative 12. I could divide everything by negative 1. So I get x plus y. It's got to be, sorry. So now I would get x plus y greater than or equal to 12. Okay, as one of my other, does everybody see how I did that, hopefully? Okay, so I now have two equations here. So I know that x plus y has got to be less than or equal to 15, but it's got to be more than or equal to 12. Okay, oops, sorry, slid that down a little bit. Okay, so now let's note a couple of other things for sure. We know that x, the number of cars from Millville to Camden, the number of cars from Millville to Camden, since it's cheaper than Trenton to Camden, we know for sure we want to send at least some, well, some or none, so it's got to be greater than or equal to 0. It could be equal to 0. It's got to be some, though, greater than or equal to 0. And the number of cars from Millville to Atlantic City has got to be greater than or equal to 0. The number of cars from Trenton to Camden, so 10 minus x, got to be bigger than or equal to 0. And from Trenton to Atlantic City, it's got to be bigger than or equal to 0. So if I solve this problem here, if I just add the x over, I get 10 is bigger than or equal to x, and y, or sorry, and 12, same thing down here. We add the y over, we get 12 is bigger than or equal to y. We might want to rewrite this so that it looks kind of more like these. So we know that x has to be less than or equal to 10, and we know that y has to be less than or equal to 12. Okay? All right. So we have those equations there. So we have this equation, this equation, this equation, this equation. We also have this equation, and we have this equation. So there's our four kind of constraints, if you will. Let's come up with our objective equation. Do you remember how to do that? Well, for the objective equation, we're going to look at the last sentence again. The last sentence says, how many cars should be moved from each warehouse to each dealership to fill the orders at minimum cost? So we're looking for a cost here. We're looking for a cost equation. And the cost equation, so if you think about it, how much does it cost? How much does it cost to move from Millville to Camden? It costs $50. So we know that 50x plus how much does it cost to move from Millville to Atlantic City, which is 40y. In addition to that, we have to take the cost that it's going to be from Trenton to Camden, which is $60, times how many cars, 10 minus x. Plus, in addition to that, we have the cost from Trenton to Atlantic City, which is $55, times how many cars, which is 12 minus y. So this is our cost equation. We could actually do some simplification here and come up with the fact that the cost equals, let's do a little bit of math right here. So 60 times 10 is 600 minus 60x. 55 times 12, get out your calculators. Woo-woo! 55 times 12, I get 660 minus 55y. Now, combining like terms, 600 plus 660, that's going to give me 1260. 50x minus 60x, it's going to give me a negative 10x. And 40y minus 50y is going to give me a negative 15y. So there's my cost. Oops, let me just move that out a little bit, sorry. Make this a little bit nicer for you. That's y plus 1260. And there is our cost equation. Okay, so let's go ahead and graph this sucker up with our constraints. Okay, so we have this constraint here that x has to be bigger than or equal to 0. So that's this line right here, going this way. It says y has to be bigger than or equal to 0. That's this line right here, going this way. So far it's in this region. It also tells me that x has to be less than or equal to 10. So if I come out here to 10, draw a line, it's got to be this way. And it says y has to be less than or equal to 12. So let's call this 12. It's got to be here. So, okay, that's now bringing us to here. We also have this equation right here. It says x plus y has to be greater than or equal to 12. So that's going to have a y-intercept of 12 if I put in 0 for x. Y equals 12. If I put in 0 for y, I get x equals 12. So come here to 12, and that's this point right here. So that's this line right there. And it says it has to be bigger than, so it's going to be above. So now we're only looking at this region right here. This region is now no longer part of it. Okay, and then this equation up here, if I look at the x-intercept, says if I let y be 0, x is 15. So if that's 12, then here's say is 15. And if I look at the y-intercept, when x is 0, I get y equals 15. So that's going to be like right about here, 15-ish. And it's got to be less than that, so it's got to be here. So now we're talking about this region right here. There's our region we're looking at. We want this point, this point, this point, and this point. Okay, so we already know this point right here. This point we know is 0, 12. So that could be values we put in for x and for y and see what our cost is. So let's do that right now. So our cost, if it's 0 and 12, would be negative 10 times 0 plus negative 15 times 12 plus 1260. So let's see, negative 15 times 12 gives me negative 180 plus 1260 is 1440. So here the cost is 1440. Okay? We need to find this point, and this point. So this point here is on this line, right here. It's on this one. It's on the x plus y equals 12 equation. And x we're going to let to be 10, because that's where this line right here is at 10. So if I have 10 plus y equals 12, then I get y equals 2. So that would be the point 10, 2. So that'd be, so I take 10 cars, so I'm going to let 10 go in for x, so my cost. So my cost here is going to be negative 10 times 10 plus negative 15 times 2 plus 1260. It's going to be negative a hundo. It's going to be negative 30. So then what's 1260 minus 130? It's going to be 1130. So the cost here is 1130, which is cheaper than that cost. So we know that this one is out for sure. This one is a possibility at 10.2. Okay? All right, so now we got to find this point up here and this point here, which means we're going to use this equation right up here, this one right here, x plus y equals 15, because they're on that line. Okay? So if I have the equation, I'm going to do it right over here. X plus y equals 15. That's the equation we're going to use. We're going to let x be 10. So if I have 10 here, I get y is 5. So that's going to be the point 10, 5. So I come back here, and I say my cost is equal to negative 10 times 10 plus negative 15 times 5 plus 1260. So doing some math, negative 100 plus negative 75 plus 1260. I mean, I'm hoping you're seeing that this one's going to be cheaper than that one, but, you know, if not, it's okay. Let's do the math. 1260 minus 175 That gives us 1,085. Oh, well, that's actually a good thing because we want the cheapest one. So this one is now out. This one is out. This one's out. This one's so far our top lead, 10.5. Now let's find this point here. I don't know what the 10 is, but I know the y is 12, so we know that x plus y, so x plus 12, it's got to equal 15. Subtract 12, we get x equals 3. So therefore, that's the point 312. So I plug that in. So my cost is negative 10 times 3 plus negative 15 times 12 plus 1260. We're going to get, so that's going to be negative 30 plus 15 times 12 is 180, so negative 180. So negative 30 plus negative 180 is negative 210. So 1260 minus 210, that gives me 1,050. Okay, we want again the cheapest or the least amount of cost. Is it the 1440? No. Is it the 1130? No. Is it the 1085? No. So that means this one's out. Okay, the 10.5 is out. This one right here is the cheapest, 312. So 312 gives us the cheapest amount of cost, 1,050. So what is 3 again? Well, if you remember correctly, back here now at our diagram, x is 3, y is 12. So how many cars from Millville to Camden? 3. How many cars from Millville to Atlantic City? 12. How many cars from Trenton to Camden? 10 minus 3. Well, 10 minus 3 is 7. How many cars from Trenton to Atlantic City? 12 minus 12. 0. So don't take any from Trenton to Atlantic City. You're going to take 7 up from Trenton to Camden, 3 up from Millville to Camden, so 7 plus 3 is 10. Then you're going to take 12 down to Atlantic City from Millville, that's 12. And there you go. That's how many from each warehouse should be done. Whew! What a problem. All right, folks. I don't think there'll be one like that on the test, but, you know, you never know. Okay, I'm going to make another video real quick, and have a good day. See ya. Bye. At 1050. Linear programming slide 15. Now, can I say change? What does it say too? Google Drive. Where at my Google Drive? Just my Google Drive.